Welcome to the channel NextGen Tech Prep. In today's video, we are diving deep into essential questions and comprehensive answers for the Google Professional Cloud Security Engineer certification. Whether you're preparing for an exam or just looking to sharpen your knowledge, you're in the right place. If you find this content valuable, please hit that subscribe button and ring the notification bell so you never miss an update. Now, let's get started.
A customer has an analytics workload running on Compute Engine that should have limited internet access. Your team created an egress firewall rule to deny, priority 1000, all traffic to the internet. The Compute Engine instances now need to reach out to the public repository to get security updates. What should your team do? The options are: Option A, create an egress firewall rule to allow traffic to the CIDR range of the repository with a priority greater than 1000. Option B, create an egress firewall rule to allow traffic to the CIDR range of the repository with a priority less than 1000. Option C, create an egress firewall rule to allow traffic to the hostname of the repository with a priority greater than 1000. Option D, create an egress firewall rule to allow traffic to the hostname of the repository with a priority less than 1000.
To arrive at the correct answer, we focus on the keywords: egress firewall rule to deny, priority 1000, reach out to the public repository.
The correct answer is option B, create an egress firewall rule to allow traffic to the CIDR range of the repository with a priority less than 1000.
Why is this correct? B. In Google Cloud VPC, lower priority numbers indicate higher precedence. To override the deny rule, priority 1000, the new allow rule must have a priority less than 1000. Additionally, firewall rules are based on IP addresses or CIDR ranges, not hostnames. Why are the others incorrect? A priority greater than 1000 means lower precedence, so this allow rule would be evaluated after the deny rule and thus have no effect. C. Firewall rules use IP addresses or CIDR ranges, not hostnames. Additionally, a priority greater than 1000 means lower precedence than the deny rule. D. While a priority less than 1000 correctly provides higher precedence, GCP VPC firewall rules are created using IP addresses or CIDR ranges, not hostnames.
A customer wants to deploy a large number of 3-tier web applications on Compute Engine. How should the customer ensure authenticated network separation between the different tiers of the application? The options are: Option A, run each tier in its own project and segregate using project labels. Option B, run each tier with a different service account, SA, and use SA-based firewall rules. Option C, run each tier in its own subnet and use subnet-based firewall rules. Option D, run each tier with its own VM tags and use tag-based firewall rules.
To arrive at the correct answer, we focus on the keywords: 3-tier web applications, Compute Engine, authenticated network separation, different tiers.
The correct answer is option B, run each tier with a different service account, SA, and use SA-based firewall rules.
Why is this correct? B. Service accounts, SAs, provide an authenticated identity for Compute Engine VMs. Using SA-based firewall rules ensures strict, authenticated network separation between application tiers, as rules are enforced based on cryptographic identity rather than IP addresses or simple strings. Why are the others incorrect? A. Placing each tier in a separate project creates excessive management overhead, and project labels do not enforce network traffic separation or firewall rules. C. Subnet-based firewall rules rely on IP ranges, which provide network separation but lack the requested cryptographic authentication of the instances. D. VM tags are arbitrary, mutable strings that do not provide strongly authenticated identity for network separation, unlike service accounts.
You manage a fleet of virtual machines, VMs, in your organization. You have encountered issues with lack of patching in many VMs. You need to automate regular patching in your VMs and view the patch management data across multiple projects. What should you do? Choose 2. The options are: Option A, view patch management data in VM Manager by using OS Patch Management. Option B, view patch management data in Artifact Registry. Option C, view patch management data in a Security Command Center dashboard. Option D, deploy patches with Security Command Center by using Rapid Vulnerability Detection. Option E, deploy patches with VM Manager by using OS Patch Management.
To arrive at the correct answer, we focus on the keywords: virtual machines, VMs, automate regular patching, view the patch management data.
The correct answers are Option A, view patch management data in VM Manager by using OS Patch Management. And Option E, deploy patches with VM Manager by using OS Patch Management.
Why is this correct? A. VM Manager's OS Patch Management provides centralized visibility, enabling you to effectively view patch compliance and management data across multiple projects. E. VM Manager includes an OS patch management service specifically designed to automate and schedule regular patch deployments across your fleet of VMs. Why are the others incorrect? B. Artifact Registry is a service for storing and managing container images and software packages, not for managing or viewing OS patch data for VMs. C. While Security Command Center manages security postures and vulnerabilities, VM Manager is the correct native tool specifically designed for viewing OS patch management data. D. Security Command Center and its Rapid Vulnerability Detection feature are used for identifying and alerting on vulnerabilities, not for automating or deploying OS patches.
Your organization is using a third-party identity and authentication provider to centrally manage users. You want to use this identity provider to grant access to the Google Cloud Console without syncing identities to Google Cloud. Users should receive permissions based on attributes. What should you do? The options are: Option A, configure the central identity provider as a Workforce Identity Pool provider in Workforce Identity Federation. Create an attribute mapping by using the Common Expression Language, CEL. Option B, configure a periodic synchronization of relevant users and groups with attributes to Cloud Identity. Activate single sign-on by using the Security Assertion Markup Language, SAML. Option C, set up the Google Cloud Identity Platform. Configure an external authentication provider by using OpenID Connect and link user accounts based on attributes. Option D, activate external identities on the identity-aware proxy. Use the Security Assertion Markup Language, SAML, to configure authentication based on attributes to the central authentication provider.
To arrive at the correct answer, we focus on the keywords: third-party identity and authentication provider, grant access to the Google Cloud Console, without syncing identities to Google Cloud, permissions based on attributes.
The correct answer is Option A, configure the central identity provider as a Workforce Identity Pool provider in Workforce Identity Federation. Create an attribute mapping by using the Common Expression Language, CEL.
Why is this correct? A. Workforce Identity Federation grants access to Google Cloud resources, including the console, using external identities without requiring user synchronization. It supports mapping identity provider attributes using CEL for attribute-based access control. Why are the others incorrect? B. This option requires periodic synchronization of users to Cloud Identity, which directly violates the requirement to grant access without syncing identities to Google Cloud. C. Identity Platform is a customer identity and access management (CIAM) solution designed for your own applications, not for granting workforce access to the Google Cloud Console. D. Identity-Aware Proxy (IAP) controls access to applications hosted on Google Cloud or on-premises, but it is not the service used for granting administrative access to the Google Cloud Console itself.
Your organization's use of the Google Cloud has grown substantially, and there are many different groups using different cloud resources independently. You must identify common misconfigurations and compliance violations across the organization and track findings for remedial action in a dashboard. What should you do? The options are: Option A, create a filter set in Cloud Asset Inventory to identify service accounts with high privileges and IAM principals with Gmail domains. Option B. Scan and alert vulnerabilities and misconfigurations by using Secure Health Analytics detectors in Security Command Center Premium. Option C. Set up filters on Cloud Audit logs to flag log entries for specific, risky API calls, and display the calls in a Cloud Log Analytics dashboard. Option D. Alert and track emerging attacks detected in your environment by using Event Threat Detection detectors.
To arrive at the correct answer, we focus on the keywords, identify common misconfigurations and compliance violations, track findings for remedial action in a dashboard.
The correct answer is option B. Scan and alert vulnerabilities and misconfigurations by using Secure Health Analytics detectors in Security Command Center Premium.
Why is this correct? B. Security Command Center Premium with Security Health Analytics automatically scans for common misconfigurations and compliance violations across Google Cloud resources, displaying findings in a centralized dashboard for tracking and remediation. Why are the others incorrect? A. Cloud Asset Inventory helps with asset discovery and history but lacks built-in scanners for vulnerabilities, misconfigurations, and compliance violations, nor does it provide a dedicated remediation dashboard. C. Cloud Audit logs track who did what and when, which is useful for activity monitoring but not designed to proactively scan for state-based misconfigurations or compliance violations. D. Event Threat Detection identifies active, emerging attacks and threats based on log data, rather than scanning resource states for misconfigurations or compliance violations.
Your company's users access data in a BigQuery table. You want to ensure they can only access the data during working hours. What should you do? The options are: Option A. Assign a BigQuery data viewer role along with an IAM condition that limits the access to specified working hours. Option B. Run a subtle script that assigns a BigQuery data viewer role and remove it only during the specified working hours. Option C. Assign a BigQuery data viewer role to a service account that adds and removes the users daily during the specified working hours. Option D. Configure Cloud Scheduler so that it triggers a Cloud Functions instance that modifies the organizational policy constraint for BigQuery during the specified working hours.
To arrive at the correct answer, we focus on the keywords, BigQuery table, only access the data during working hours.
The correct answer is option A. Assign a BigQuery data viewer role along with an IAM condition that limits the access to specified working hours.
Why is this correct? A. IAM conditions allow defining time-based access controls for Google Cloud resources. Applying a condition to the role ensures users only have access during specified working hours, providing a native, automated, and secure solution. Why are the others incorrect? B. SUDL is a command line tool for cloud storage, not BigQuery. Furthermore, managing access via custom scripts is brittle and requires unnecessary operational overhead compared to native IAM conditions. C. Using a service account to add and remove users daily requires custom scripting, scheduling, and introduces unnecessary operational overhead and potential for failure, unlike native IAM conditions. D. Organization policy constraints manage resource configurations, not dynamic time-based user access. Additionally, modifying org policies via Cloud Functions and Scheduler for this purpose is unsupported and unnecessarily complex.
You are setting up a new cloud storage bucket in your environment that is encrypted with a customer-managed encryption key, CMEK. The CMEK is stored in Cloud Key Management Service, KMS, in Project PRJA, and the cloud storage bucket will use Project PRJB. The key is backed by a Cloud Hardware Security Module, HSM, and resides in the region Europe West 3. Your storage bucket will be located in the region Europe West 1. When you create the bucket, you cannot access the key, and you need to troubleshoot why. What has caused the access issue? The options are: Option A, a firewall rule prevents the key from being accessible. Option B, Cloud HSM does not support cloud storage. Option C, the CMEK is in a different project than the cloud storage bucket. Option D, the CMEK is in a different region than the cloud storage bucket.
To arrive at the correct answer, we focus on the keywords. Customer Managed Encryption Key, CMEK, resides in the region Europe West 3. Storage bucket will be located in the region Europe West 1.
Correct answer is option D. The CMEK is in a different region than the cloud storage bucket.
Why is this correct? D. CMEK keys used to encrypt cloud storage buckets must reside in the exact same location, region or multi-region, as the bucket itself. Why are the others incorrect? A. Cloud KMS and cloud storage are managed services that use identity and access management, IAM, for access control, not VPC firewall rules. B. Cloud HSM keys are fully supported and can be used as CMEKs to encrypt cloud storage buckets. C. CMEKs can reside in a different project than the encrypted resources, which is a standard practice for centralized key management.
Your organization is moving virtual machines, VMs, to Google Cloud. You must ensure that operating system images that are used across your projects are trusted and meet your security requirements. What should you do? The options are: Option A, implement an organization policy to enforce that boot disks can only be created from images that come from the Trusted Image Project. Option B, implement an organization policy constraint that enables the shielded VM service on all projects to enforce the Trusted Image Repository usage. Option C, create a cloud function that is automatically triggered when a new virtual machine is created from the Trusted Image Repository. Verify that the image is not deprecated. Option D, automate a security scanner that verifies that no common vulnerabilities and exposures, CVEs, are present in your Trusted Image Repository.
To arrive at the correct answer, we focus on the keywords, operating system images, across your projects, trusted, security requirements.
Correct answer is option A. Implement an organization policy to enforce that boot disks can only be created from images that come from the Trusted Image Project.
Why is this correct? A. The Compute.Trusted Image Project's organization policy constraint restricts project members from creating VMs from unauthorized images, centrally enforcing the use of trusted image repositories across all projects. Why are the others incorrect? B. Shielded VM ensures rootkit-level protection and boot integrity but does not enforce restrictions on which project's images can be used to create boot disks. C. Triggering a cloud function after VM creation is a reactive measure and cannot proactively prevent users from deploying VMs using untrusted images. D. Scanning for vulnerabilities is important, but it alone does not prevent developers from provisioning instances using images from unverified sources outside the trusted repository.
You need to audit the network segmentation for your Google Cloud footprint. You currently operate production and non-production infrastructure as a service, IaaS, environments. All your VM instances are deployed without any service account customization. After observing the traffic in your custom network, you notice that all instances can communicate freely despite tag-based VPC firewall rules in place to segment traffic properly with a priority of 1000. What are the most likely reasons for this behavior? The options are: Option A, all VM instances are missing the respective network tags. Option B, all VM instances are residing in the same network subnet. Option C, all VM instances are configured with the same network route. Option D, a VPC firewall rule is allowing traffic between source/targets based on the same service account with priority 999. E. A VPC firewall rule is allowing traffic between source/targets based on the same service account with priority 1001.
To arrive at the correct answer, we focus on the keywords, deployed without any service account customization, all instances can communicate freely, despite tag-based VPC firewall rules, priority of 1000.
The correct answers are option A. All VM instances are missing the respective network tags. And option D, A VPC firewall rule is allowing traffic between source/targets based on the same service account with priority 999. A VPC firewall rule is allowing traffic between source/targets based on the same service account with priority 1001.
Why is this correct? A. If VM instances are missing the network tags specified in the firewall rules, those tag-based rules will not apply, allowing other rules to dictate traffic. D. A firewall rule based on the shared default service account with a higher priority, 999 is evaluated before 1000, would override the tag-based rules, allowing all instances to communicate. Why are the others incorrect? B. Residing in the same subnet does not bypass VPC firewall rules, which evaluate and apply to all traffic between VM instances regardless of their subnet placement. C. Network routes only determine the path for traffic, not its authorization. Firewall rules will still block or allow traffic regardless of the routes configured.
For data residency requirements, you want your secrets in Google Cloud's Secret Manager to only have payloads in Europe West 1 and Europe West 4. Your secrets must be highly available in both regions. What should you do? The options are: Option A, create your secret with a user-managed replication policy, and choose only compliant locations. Option B, create your secret with an automatic replication policy, and choose only compliant locations. Option C, create two secrets by using Terraform, one in Europe West 1 and the other in Europe West 4. Option D, create your secret with an automatic replication policy, and create an organizational policy to deny secret creation in non-compliant locations.
To arrive at the correct answer, we focus on the keywords: data residency requirements, secret manager, only have payloads in Europe West 1 and Europe West 4, highly available in both regions.
The correct answer is option A, create your secret with a user-managed replication policy, and choose only compliant locations.
Why is this correct? A. User-managed replication allows you to select specific regions, Europe West 1 and Europe West 4, for storing and replicating secret payloads, perfectly satisfying both strict data residency constraints and high availability requirements. Why are the others incorrect? B. Automatic replication stores the secret data globally across multiple regions, which violates the strict data residency requirement to restrict payloads only to Europe West 1 and Europe West 4. C. Creating two separate secrets results in independent, non-synchronized resources. This does not provide high availability or automatic failover for a single secret across regions. D. Automatic replication inherently replicates data globally. An organizational policy restricting resource location cannot override or constrain the global nature of automatic replication in Secret Manager.
After completing a security vulnerability assessment, you learned that cloud administrators leave Google Cloud CLI sessions open for days. You need to reduce the risk of attackers who might exploit these open sessions by setting these sessions to the minimum duration. What should you do? The options are: Option A, set the session duration for the Google Session Control to 1 hour. Option B, set the re-authentication frequency for the Google Cloud Session Control to 1 hour. Option C, set the organization policy constraints/IAM. Allow service account credential lifetime extension to 1 hour. Option D, set the organization policy constraints/IAM. Service account key expiry hours to 1 hour and inherit from parent to false.
To arrive at the correct answer, we focus on the keywords: Google Cloud CLI sessions open for days, reduce the risk of attackers, setting these sessions to the minimum duration.
The correct answer is option B, set the re-authentication frequency for the Google Cloud Session Control to 1 hour.
Why is this correct? B. Google Cloud Session Control manages user session lengths by requiring re-authentication. Setting the re-authentication frequency to 1 hour forces administrators to re-authenticate to the Cloud CLI, effectively reducing the risk of open sessions. Why are the others incorrect? A. The correct feature configures the re-authentication frequency, not session duration. Session duration applies to different contexts, while Cloud CLI sessions are governed by re-authentication policies. C. This organization policy constraint applies to extending the credential lifetime for service accounts, which does not affect human administrators using the Google Cloud CLI. D. This constraint enforces a maximum expiry time for user-managed service account keys. It is irrelevant to managing human user sessions in the Cloud CLI.
You manage one of your organization's Google Cloud projects, Project A. A VPC Service Control (SC) perimeter is blocking API access requests to this project, including pub/sub. A resource running under a service account in another project, Project B, needs to collect messages from a pub/sub topic in your project. Project B is not included in a VPC SC perimeter. You need to provide access from Project B to the pub/sub topic in Project A using the principle of least privilege. What should you do? The options are: Option A, configure an ingress policy for the perimeter in Project A, and allow access for the service account in Project B to collect messages. Option B, create an access level that allows a developer in Project B to subscribe to the pub/sub topic that is located in Project A. Option C, create a perimeter bridge between Project A and Project B to allow the required communication between both projects. Option D, remove the pub/sub API from the list of restricted services in the perimeter configuration for Project A.
To arrive at the correct answer, we focus on the keywords: VPC Service Control (SC), perimeter is blocking API access requests, service account in another project, Project B, needs to collect messages, Project B is not included in a VPC SC perimeter, principle of least privilege.
The correct answer is option A, configure an ingress policy for the perimeter in Project A, and allow access for the service account in Project B to collect messages.
Why is this correct? A. Ingress rules allow API clients outside a perimeter to securely access resources inside. Specifying the exact service account identity allows the required communication while adhering strictly to the principle of least privilege. Why are the others incorrect? B. Access levels provide contextual access based on attributes like IP or device. Furthermore, the scenario requires access for a service account, not a developer. C. Perimeter bridges facilitate communication between projects that reside in different VPC SC perimeters. Because Project B is not in any perimeter, a bridge cannot be used. D. Removing pub/sub from restricted services disables perimeter protection for the API across the entire project, which violates the principle of least privilege.
Your organization uses Google Workspace Enterprise Edition for authentication. You are concerned about employees leaving their laptops unattended for extended periods of time after authenticating into Google Cloud. You must prevent malicious people from using an employee's unattended laptop to modify their environment. What should you do? The options are: Option A, create a policy that requires employees to not leave their sessions open for long durations. Option B, review and disable unnecessary Google Cloud APIs. Option C, require strong passwords and 2SV through a security token or Google Authenticator. Option D, set the session length timeout for Google Cloud services to a shorter duration.
To arrive at the correct answer, we focus on the keywords: employees leaving their laptops unattended for extended periods of time, prevent malicious people from using an employee's unattended laptop.
The correct answer is option D, set the session length timeout for Google Cloud services to a shorter duration.
Why is this correct? D. Setting a shorter session length timeout automatically terminates the session after a period of inactivity, directly mitigating the risk of unauthorized access on an unattended laptop. Why are the others incorrect? A. Administrative policies rely on human compliance rather than technical controls, meaning they cannot proactively enforce session termination on unattended laptops. B. Disabling APIs reduces the overall attack surface but provides no protection for active, unattended sessions that already have access. C. Strong passwords and two-step verification secure the initial authentication process but do not protect a session after the user has already logged in.
You are a cloud identity administrator for your organization. In your Google Cloud environment, groups are used to manage user permissions. Each application team has a dedicated group. Your team is responsible for creating these groups, and the application teams can manage the team members on their own through the Google Cloud Console. You must ensure that the application teams can only add users from within your organization to their groups. What should you do? The options are: Option A, change the configuration of the relevant groups in the Google Workspace Admin Console to prevent external users from being added to the group. Option B, set an Identity and Access Management (IAM) policy that includes a condition that restricts group membership to user principals that belong to your organization. Option C, define an Identity and Access Management (IAM) deny policy that denies the assignment of principals that are outside your organization to the groups in scope. Option D, export the cloud identity logs to BigQuery. Configure an alert for external members added to groups. Have the alert trigger a Cloud Function instance that removes the external members from the group.
To arrive at the correct answer, we focus on the keywords. Application teams can manage the team members on their own. Ensure that the application teams can only add users from within your organization to their groups.
The correct answer is Option A. Change the configuration of the relevant groups in the Google Workspace Admin Console to prevent external users from being added to the group.
Why is this correct? A. Google Workspace or Cloud Identity Group settings allow administrators to proactively restrict membership to internal users only. This native configuration directly meets the requirement without complex workarounds. Why are the others incorrect? B. IAM policies grant or deny access to Google Cloud resources for existing identities. They do not manage or restrict who can be added as a member to a cloud identity group. C. IAM deny policies restrict actions on Google Cloud resources. They cannot be applied to restrict membership additions or manage who can join Google Workspace or Cloud identity groups. D. This is a complex, reactive custom solution that removes members after they are already added, which is suboptimal compared to natively preventing their addition in the first place.
You plan to use a Google Cloud Armor policy to prevent common attacks such as cross-site scripting, XSS, and SQL injection, SQLi, from reaching your web application's backend. What are 2 requirements for using Google Cloud Armor security policies? Choose 2. The options are: Option A, the load balancer must be an external SSL proxy load balancer. Option B, Google Cloud Armor policy rules can only match on Layer 7, L7 attributes. Option C, the load balancer must use the Premium Network Service tier. Option D, the backend services load balancing scheme must be external. Option E, the load balancer must be an external HTTPS load balancer.
To arrive at the correct answer, we focus on the keywords: Google Cloud Armor policy, 2 requirements, Google Cloud Armor security policies.
The correct answers are Option D. The backend services load balancing scheme must be external. And Option E. The load balancer must be an external HTTPS load balancer.
Why is this correct? D. Cloud Armor security policies are attached to backend services, and the backend services load balancing scheme must be configured as external. E. Cloud Armor requires an external HTTPS load balancer, as it inspects incoming HTTP/HTTPS traffic to protect backend applications. Why are the others incorrect? A. Cloud Armor does not support external SSL proxy load balancers. It is specifically designed to work with external HTTPS load balancers. B. Cloud Armor policy rules can evaluate Layer 3 and Layer 4 attributes, such as IP addresses, in addition to Layer 7 attributes. C. Cloud Armor does not exclusively require the Premium Network Service tier, it can also function with the standard network service tier.